Okay, so, excuse me, we've determined that f and g are not inverses, or that g is not the inverse of our function f of x equals 2x plus 3. But we do know by looking at a picture, if we were to graph it, or the discussion we had earlier, that f really is a one-to-one function. And so because it's one-to-one, then it is going to have an inverse. And so the next thing that we'll tackle is we'll say, find the inverse of f of x equals 2x plus 3. Now, if I want to find the inverse of a function, where we'll start is we're going to replace f of x with y. I know this equation really is just y equals 2x plus 3. And so f of x is just another name for y. Then every place there's a y in my equation, I'm going to put an x. And every place there's an x, I'm going to put a y. Okay. If it said x squared, I would change it to y squared. If it said 1 over x, I would change it to 1 over y. But every place there's a y, I'm going to rewrite it with x's. Every place there's an x, I'm going to rewrite it with y's. From here, then I'm going to solve this equation for y. Okay. So subtract 3 from both sides, divide everything by 2. It says y equals 1/2 x minus 3/2. If I'm able to do this successfully, what that means is this is the inverse of the function that I started with. So I will replace all of the x's with y's. I will replace all y's with x's, and then solve the new equation for y. That comes back to our first page diagram where we know that AB is on one graph and BA is on the other. The domain of one is the range of the other. All of those ideas hooked together lead us to this, this method here. Okay. Now again, when you go to your exercises, they're not all straight lines. I think there is at least one line that you get to play with of each type of problem. Okay, but when we solve the new equation for y, it should be something that we know how to solve because we've discussed it in a previous section. All right, so usually someone somewhere along the way is thinking, why in the world do I care that the inverse of y equals 2x plus 3 is y equals 1/2 x minus 3/2? Okay. And in all fairness, with straight lines especially, we don't really, I'm not going to say there's not a situation ever, but lines are not the functions that we're going to be working with. Some of these rational things that you'll see in your exercises, not what we're going to be working with later in the chapter. Okay, the idea and the feel for section 4.1, and my videos have been kind of shaky, so I apologize, is getting the understanding down of what functions have inverses, okay, and how they work. So the sing-along that we usually do when we're together in class is I start every class and I say, does every function have an inverse? And you guys all say no. And I say, well, how do I tell by looking? No. What kind of functions have inverses? And then you'll tell me one-to-one functions have inverses. And I'll say, how can I tell by looking at a function whether or not it's one-to-one? Then you will all tell me horizontal line test. Okay, and so you'll just have to have that sing-along in your head every time you sit down to do this. But only one-to-one functions have inverses. And I've lost my photo. The domain of one is the range of the other, and all of these things on this page, this is the snapshot you need to have in your brain and the little doodle you need to have beside you as you're working through these, as we're making connections and hooking these ideas together. A function only has an inverse if it's one-to-one. Okay, that's the only way I can undo it. If I do look at a picture, maybe I don't have the equation, but I have a picture of the blue function, I can draw the green function. I can draw a picture of that inverse without knowing anything else about it because I know this relationship to this line here, y equals x. I know that it has symmetry with respect to that. If I'm given two functions, I can determine whether or not they're inverses by plugging one into the other. And if I get plain old x out of that, I know I've done things correctly Okay, so for example, if I take 2x plus 3, and instead of x, I plug in this new found inverse, this thing in the box down below. It says x minus 3 plus 3, which when I clean it up, does leave me with plain old x. Okay, I can check my work and say, yes, this is really correctly the inverse that I found. If that didn't make any sense, but that is the correct inverse for the function that I started with. Okay, these are the relationships that we have to understand, the ideas and the concepts we have to connect to be able to go on and tackle the types of functions that we're going to look at the rest of the semester, or the rest of the chapter, not semester, fortunately. Okay, so get a hold of me if you have questions.